So we'll try to create this table called as books, and we'll try to create this table called as members. Don't worry about the data types. Don't worry about the constraints for now, because in the same session we'll be talking about all this in some time. So for now, just copy paste and run the commands. So what we are going to do is we are going to run the queries against the database. So I'll try to create the books table first. So the books table contains book ID, title, and category. So let me run this query. Okay, I want to run against this database. All right, so we have the books table, and I'll try to insert these records. If you notice, we are trying to insert a null value. Don't worry guys, we are yet to see all these commands: create, insert, alter, delete, drop. All right, and then let me try to create the members table. So let us try to insert the records into the members table. All right, the tables are ready, and let us jump into the joins. So I want you guys to put your full attention, guys. So let me try to select the data for you. Select star from books. I made a mistake in this. Okay, can you see we have the data? I can definitely commit it, but you will understand the details of committing or not committing in some time, because that's also topic of the day. All right. So in the books table, we have the data. We have 9 columns and 9 records, and you see in the category we have the last record as null, so I put it wantedly. Okay, and then select star from members. Perfect. Now we have these two tables, right? Let's get into join syntax. As I mentioned, we have traditional way of joining and the join syntax as provided by the Oracle. Inner join. Very simple. It's a simple join between two or more tables which returns rows that satisfy the join condition. Now these are the two tables. The traditional join method. In traditional join method, what happens guys? You specify all the tables in the from clause, whatever the tables you want to join, and the join condition you specify under the where clause. It's very simple. It's a plain English statement that you can read and understand. And if you have something like this, it's a traditional method of joining tables, and it is the simplest English like sentences. Okay. Now in this case, what we are trying to do is we are trying to select the member name, and we are trying to select the category of the book that they have borrowed from the library. So we are technically querying the member name from table 2 and category from table 1. This is how we are querying these two columns. But these two columns, we can get the output by joining on the key columns. So which is the key column common in both the tables? It's book underscore ID. So what we do is we join these two tables based on the book ID, and then we will only take the member name and category columns in the output. So we are projecting select member name category from members M, books B. Remember guys, these are table name alias. So in the entire query, rather than typing the entire members, I can just type M, and SQL knows which table to query. So in this select part, in the projection part, we have to tell from which table the column is coming, because now we have multiple tables. If you have one single table in the query, you don't need to specify the table name dot column name. You can directly write the column name. But in this case, we have multiple tables, so SQL gets confused from which table to pick up the column names. In this case, it's always good to specify the table name dot column name. So in our case, I want member name from the members table, so m dot member name, and I want category from the books table, so it's b dot category. In the where clause, I am telling wherever members dot book ID is matching books dot book ID. That's the condition I'm saying. So wherever the book IDs are matching, we will get the output for member name and category. Let us try to check these two tables. So we see that the book ID 3 is available in the table 2 and book ID 3 is available in table 1. That means the category Inspire and the member name John will be in the output. So let us try to match the output. Can you see we have John and we have Inspire as the category, right? The same goes with book ID number 5. So 5 is available in this column and 5 is available over here. So for Max, the category is novel. So our second record is Max and the category is novel. The same goes with book ID number 6. So Sam borrowed the book ID called 6, which is under business category. So our next output is Sam and category is business. See, in this case, we have one key column, right? But remember when we were looking at normalization, we had composite key. What is a composite key? It's a key which is collection of two or more columns. So two or more columns will uniquely define a composite key or a single record inside the table. Now in those kind of situation, you can definitely specify more columns in the equation part. All right, coming back to Leo. Leo book ID is 7 and 7 matches over here. So Leo book category is sales. And finally we have Kish. The book ID is 9. Book ID is 9. The category is null. So we have Kish in the output, but the category is null. So that's how the inner join works in a traditional method, right? Can you see carefully watch the join condition? It says return the rows where book ID column values are matching from members and books table. What I'll do is I'll try to run this query for you guys. So what we are doing is select m dot member ID b dot category from members m books b where m dot book underscore ID is same as b dot book underscore ID. So let us run this query. Now can you see we have the exactly same, okay, I selected member ID rather than member name. Guys, there is no limitation on the columns that you can project in the output. Now that you're joining the two tables, it depends whatever columns you need in the output until unless the join condition is met, right? So we can see that John took a book that's under Inspire category. Max took a book that's under novel category. Sam under business category. Leo under sales category. Kish null. There is no category for the book that is taken by Kish. Perfect. That's traditional method of joining two tables. So once again, in traditional method, you specify all the table names in the from clause and the join condition under the where clause. Now, what is the SQL join method? Under SQL join, you use the join keyword to join the tables. So if you compare this one with the traditional method, rather than a comma separated table names, we have a keyword called as join. So select whatever your columns are from the table name, join the second table name. And if you have more, you continue to use the join keyword again and again in the from clause. Then you specify on. Okay. So understand, remember guys, in our last session, I was stressing on this one. If the key column names are same in both the tables, then rather than using join on, you can actually use the using keyword and only specify the key column. So I have given example of both the queries for your understanding, but sometimes or most of the times when you work in real time, the key column names might be different in the tables. In that case, you have to specify the table dot key column name in the first table that is equal to table dot key column name into the second table. So let me run this query for you and we'll check the output. First, we have already seen the traditional method. So select m dot member name. I want to know the member name and I want to know the book dot title. Book title. I want to know book dot category from members M. Join. I'm joining on books B, and then you specify, there are two ways to specify the join condition. If the column names, the key column names are different, then use this method m dot book underscore id equal to b dot book underscore id. So we'll run this command and we see we have the same output, but now we also have the title column from the books table, right? But now we know that the column name is same. Rather than like this, what you can do, you can use using and specify the key column in the brackets. Try to run this command and we should get the exactly same output. All right. In natural join, Oracle knows on which column to join. Oracle is already aware about your key columns. So let us try to run the same query using natural join. So select m dot member name, comma b dot title, b dot category from members M, natural join books B. That's it. You don't specify the column on which you want to join because Oracle will pick up the key columns and it will join for you. If your tables are very simple and if you are confident about the relational model that you have specific key columns, then use the natural join. In real time, it is not used because you want to have more grip on the columns on which you are joining your tables. So it's not used in real time. I mean, I haven't seen it being used in real time much. It's good to know, but don't use it in real time.